with the row operations, okay? So for the next part, we have more specific, we're going to solve actually system of equations using matrices, okay? So if you want to use an augmented matrix and row operations, well, we're going to use what we call the row-echelon form, okay? The row-echelon form will allow you to solve your system of equations fairly easy, okay? So what's the deal here? A matrix is in row-echelon form when the entry in row 1, column 1, aka this one, is 1, okay? And zeros appear below it. So this one, it seems that it's being compliant with the first step. The second the second condition that needs to happen is the first non-zero entry in each row after the first row is 1. Zeros will appear below it, and it appears to the right of the first non-zero entry in a row above, okay? So basically they are talking about this one. You need to have zeros below. At the top, you can have numbers, okay? Any rows that contain zeros to the left of the vertical bar appear at the bottom, true, okay? So at the left side, you need to have zeros. At the right side, you might have zeros or numbers, okay? This is the row-echelon form. In a second, we're going to go over what's the reduced row-echelon form, but this is going to be the row-echelon form. When you have the row-echelon form, remember, we're always going back to the original. You know that this is going to be your x's, your y's, your z's, and then your constants. Meaning here you know that z is equal to -3, okay? So it's pretty easy to see that you already have your first solution. After that, you're going to tell me, wait, this is going to be y plus 3z equals 12 indeed, okay? Since you have this, you can just plug it in and find the y. Okay, and this one, you know that it's going to be x plus 5y minus 6z equals 3. So since you have the z and the y, you would be able to solve it, no problem. Okay, so that's why we call the row-echelon form. And in general, most of the calculators and computers, they use the row-echelon form when you are trying to solve a linear system of equations, okay, in general. Okay, so if we try to solve a system of linear equations using matrices, the first thing that you need to do here is the system of equations, you are going to rewrite it as an augmented matrix, okay? Make sure that it's in order. Remember x, y, and then the constant after the equal, like this. After that, you are going to perform the row operations, okay? In this case, since you want this to be a 1, I interchange row 2 by row 1, and I have this. After that, I just interchange row 1 and row 2, okay? After that, since I want this to be a 0, I need to multiply row number 1 times -3 and add it to row number 2, and I have this equation, okay? And then I have this situation, and you're like, wait, is this in row-echelon form? Actually, it's not. Why? Because the diagonal needs to be full of 1s, and here you have a -4. How can we make that -4 a 1? Well, you know that if we multiply a -4 times -1/4, you will have a +1. So the only condition is all that row needs to be multiplied by -1/4. So you do that. The 0 times -1/4 is 0. The -1/4 times 4 is 1, and the -1/4 times -8 is +2. So this is in row-echelon form, okay? After that, you basically can solve it. Why? Because you know that y is equal to 2, and then you have that x plus 5y equals 7, and then you can solve it. So you have that the solution, you can represent it as an ordered pair, or you can always represent it as x equals y equals. That's, you know, that's a style thing, okay? Both styles would be okay. So on your notes, instead of you writing all of this, I gave you basically the little square that the book has, so you don't need to you know, rewrite it by hand, okay? So the next part, I'm going to basically use the calculator so you can see how simple is this. The only thing that you do need to remember is how to pass the system of equations to the augmented matrix, okay? So as you can see here, you can see it by hand, but you can always use the calculator, especially now that we're in this online situation. Okay, so I'm going to just cover that for now, and you're going to see that we're going to end up with the same answer, of course. Okay, so we have xyz, the constant xyz, constant xyz, constant. Okay, so I have my augmented matrix. Okay, so now I need you to bring your calculator. Okay, doesn't matter if you don't have a CAS, the CX should work fine. Okay, so of course you're going to press it on. Okay, so you are going to have your calculator here. You calculate. Okay, as you can see, I was already doing matrices, but the first thing that you're going to do, you go to menu. Okay, you go to matrix, and you're going to create your matrix. Okay, so remember, menu, matrix, and vectors, create. Okay, after that, you want to create a matrix. Okay, your matrix, the number of rows of your matrix is what? 1, 2, 3. Okay, so make sure to put the 3, then put this arrow. Okay, otherwise the calculator try to move it. Okay, then you have 4 columns, arrow down. Okay. Okay, so this is the size of the matrix that we have. Okay, so the only tedious part is you do need to complete the matrix. Okay, so you have I already messed up there. 4, 2, then you have that it's -2, then it's going to be -3, then you have a 1, then here at the bottom you have -1, then you have a 2, then you have a -3, over here you have a 5, a 16, and then you have a -1 here. Okay, so make sure that it's blinking over here, and then I would put control bar. Okay, so you're going to see this little arrow. I'm going to save this matrix as, I don't know, let's call it M as matrix. Okay, so this matrix is going to be called M. Okay, now you are going to be like, why do you want that? Well, here in menu, matrix vector, I'm seeing this row-echelon form. Okay, so when you put the row-echelon form, I have to put my M. Remember, if it's bolded, it's because I'm saving already values in that M. So you have that this is going to be equal to this situation, and you're going to be like, wait, those numbers are not user-friendly. Well, that's fine. Okay, so you just write it down. This is going to be your row-echelon form. Okay, so row-echelon form. Okay, so I just copy the values that I have. In this situation, I have 1, 0, 0, -3/4, 1, 0, 1/2, -6/7, 1 line. Then you have 4, -27, and then 1. Okay, so this is the row-echelon form. Okay, but you're like, okay, but here at matrix vector, I saw that we have a reduced row-echelon form. Well, instead of solving only this one and then doing one by one, I can just go to the reduced row-echelon form and put the M, okay, and actually solve it. Okay, so this is beautiful. Why? Because you know that x is equal to 2, y is equal to -2, and z is equal to 1. So this is the reduce, okay, reduce row-echelon form. Okay, obviously you have x equals 2, y equals -2, and z equals 1. Okay, and guess what? Here it took me like, I don't know, maybe 20 minutes, and I have exactly the same thing. Okay, isn't that nice? Okay, so you don't need to use the graphic utility. I mean, you can, but I mean, you don't need to. This method with the row-echelon form is just beautiful. Okay, so that's for that. Okay.